Hey everyone, welcome back. If you've been following along with these El Nino updates, you already know things have been heating up, and I mean that quite literally. But what I'm about to show you today is on a completely different level from anything we've discussed before. The Pacific Ocean is doing something right now that I genuinely did not expect to be talking about this early in the year, and it has enormous implications for what the United States and much of the world is going to experience, weather-wise, heading into fall and the winter of 2026 into 2027. So settle in, because this one is going to cover a lot of ground. Before we dive in, if you've been finding these updates valuable, and I know a lot of you have because the comments and messages don't lie, please take a second to subscribe. Hit that bell so you actually get notified when these go up. And if you think someone you know needs to hear this, share it with them. Okay, let's get into it. Let's start with where we actually are right now, because the sea surface temperature picture has changed dramatically compared to even a couple of weeks ago. When I looked at this data the last time I gave you a full breakdown, it was already concerning. But what has happened in the time since has honestly caught even seasoned forecasters off guard in terms of the sheer pace of this thing. The Niño 1+2 region, Pomots. That's the zone sitting right along the coast of Peru in the far eastern Pacific, and it tends to be the first place where El Nino signatures really start to show themselves. Or that area is currently running somewhere between 3 and 4 degrees Celsius, above what we'd normally expect for this time of year. That's not a small number. That is a substantial, head-turning anomaly, and we were only in mid-June. Moving westward from there, the Niño 3 region is sitting at roughly 1.83 degrees Celsius above average. The Niño 3.4 region, which is actually the primary benchmark that climate scientists use when they're officially classifying El Nino strength, is currently at about 1.61 degrees above normal. And then out in the Niño 4 region, further into the central Pacific, you're looking at around 1.32 degrees above average. Now, when you step back and look at all 4 of those regions together, what this collective picture is telling us is that we already, right now, today, are operating in what would be classified as strong to very strong El Nino territory. This isn't something being projected 6 months from now. This is happening as we speak. If you pull up a raw sea surface temperature anomaly map without any labels on it, you can literally see that warm red tongue of water extending off the coast of Peru and Central America and stretching westward across the eastern and central Pacific. It's visually striking. That warmth isn't sitting still either. It's actively spreading further west. And the rate at which it's doing so is what's really alarming people who watch this stuff closely. Now here's where it gets even more interesting, and honestly more concerning. What's happening at the ocean's surface is only part of the story. Below the surface, in what we call the subsurface temperature anomaly, the situation is even more extreme. When we look at ocean temperatures beneath the surface, we're seeing readings running 5 to 7 degrees Celsius, above average in many areas. And in parts of the far eastern Pacific, there are pockets where subsurface temperatures are running 7 to 9 degrees above normal. Let me put that in perspective for a second. That is not just unusual, that is historically unprecedented for the time of year we're in. We're talking mid-June, not September, not August. June. And these subsurface temperatures are enormously important because they represent the fuel reservoir for what's sitting above them. The warmer the subsurface, the more material there is to feed ongoing and future surface warming. This is essentially El Nino loading up for the months ahead. What ties all of this together from a scientific standpoint is something called the thermocline index, which gives us a sense of how ocean heat is being redistributed vertically. Right now that index has turned exceptionally negative, which is a direct signal that a major downwelling oceanic Kelvin wave has emerged in the eastern Pacific and is actively spreading westward. Think of a Kelvin wave as an underwater pulse of warm water. When it downwells, it pushes warmth deeper and further west, suppressing the cooler water that would otherwise upwell and moderate surface temperatures. This is the ocean's way of locking in and amplifying what's already happening at the surface. And the signal we're seeing right now is about as strong as these signals get. The upper 300-metre ocean heat content index superficie, which essentially tells us how much stored heat exists in the upper layers of the ocean, is awash in above-average anomalies across the central and eastern Pacific. The only counterpoint is a small region in the far western Pacific, showing some cooler water that appears to be trying to upwell slightly. But based on everything else we're observing, that is unlikely to put any kind of meaningful brake on this system's momentum. And when you look at tropical cyclone heat potential anomalies, a metric that tells us how much energy the ocean can feed to any storm system that develops, the eastern Pacific is showing values in roughly the 75th to 95th percentile range. In practical terms, that means any hurricane or typhoon that spins up in these waters will have enormous amounts of fuel available to it. The eastern Pacific and even parts of the western Pacific are primed for intense tropical activity this season. Okay, so let's zoom out for a second because I want to make sure everyone watching understands the physical difference between what El Niño is actually doing compared to its counterpart La Niña. Because these two patterns have very different downstream effects, and knowing which one we're in matters a great deal for understanding what your winter might actually look like. During El Niño, the trade winds, those persistent east to west winds that normally push warm surface water toward the western Pacific, weaken or even reverse in parts of the central and western Pacific. When that happens, that accumulated warm water effectively sloshes back eastward. More thunderstorm activity and atmospheric convection gets displaced into the central and eastern Pacific, rather than sitting over Indonesia and Australia where it normally lives. The Atlantic hurricane season gets suppressed by increased wind shear, which is essentially the ocean's way of tilting the playing field against Atlantic storm formation. The eastern Pacific and central Pacific hurricane seasons, meanwhile, tend to be considerably more active. What we recently saw over the last couple of weeks was a particularly dramatic example of this. Westerly wind anomalies raced across essentially the entire Pacific basin. And that event is directly responsible for the accelerated intensification we're now observing in sea surface temperature readings. La Niña, on the other hand, is essentially the mirror image. Trade winds strengthen, warm water stays piled up in the western Pacific, convection gets anchored over Australia and Indonesia, and the polar jet stream becomes more energetic and pushes colder Canadian air down into the lower latitudes of the United States. That's the pattern that drove the cold winters many of you experienced in recent years across the northern plains. But that's all about to flip, and flip hard. During El Niño winters, the Pacific jet stream extends further south and east than normal, acting like a conveyor belt for storm systems that get funneled into California, the desert southwest, the Four Corners region, and across the deep south toward the southeast. Meanwhile, the polar jet tends to get suppressed or displaced, which means a weaker cold air connection from Canada. El Niño winters across the southern tier of the United States tend to be dramatically wetter and stormier. If you live in California, the southeast, or the Gulf Coast, you need to be paying very close attention to what unfolds this fall. Now, one of the critical things forecasters track beyond just the ocean temperatures themselves is whether the atmosphere is actually responding to and coupling with what the ocean is doing. Because an El Niño that's only expressed in the ocean but not in the atmosphere is a much weaker beast than one where the two systems are talking to each other. Right now, they are absolutely talking to each other. One of the clearest ways to see this is through the Southern Oscillation Index, or SOI, which measures the pressure difference between Tahiti in the Central Pacific and Darwin, Australia. When El Niño is active, pressure drops over the eastern and central Pacific and rises over Australia, producing a persistently negative SOI. The 30-day average SOI right now is sitting at around negative 20.35. The 90-day average is negative 12.44. For context, you only need a sustained value of negative 7 over a 90-day window for El Niño to be officially declared. We're at nearly double that threshold right now. NOAA has declared El Niño. Australia's Bureau of Meteorology has declared it. There is no ambiguity here whatsoever about what phase we're in. The European Ensemble Atmospheric Forecasting System is also showing something very telling right now. Westerly wind anomalies, the reverse direction winds that reinforce El Niño's structure, are projected to persist through the rest of June and into July. And at the 200 millibar level, roughly the altitude at which commercial aircraft cruise, there is strong upper-level divergence, collocated right over the areas of the ocean with the highest sea surface temperature anomalies. That is a textbook signature of a fully coupled El Niño system. The ocean is warming the air above it, which drives atmospheric circulation changes, which in turn feed back and reinforce the ocean warming. It's a self-sustaining cycle, and right now it's running in high gear. The American GFS model Ensemble is even more aggressive in its outlook for early July, projecting intense bursts of westerly wind anomaly activity across the Pacific, that would effectively trigger another round of downwelling Kelvin wave activity. If the GFS is right about this, you would expect to see another dramatic spike in sea surface temperature anomalies heading into midsummer. The European Ensemble is somewhat more conservative, but still directionally consistent. Both models agree we're headed for continued intensification. They just differ on how violently that process unfolds over the next few weeks. Something else worth mentioning is the role of the MJO, the Madden-Julian Oscillation, which is essentially a large-scale pulse of enhanced and suppressed rainfall that travels eastward around the tropics, over roughly a 30 to 60-day cycle. The MJO's behaviour directly influences whether westerly windburst activity occurs over the Pacific, which, as we've discussed, is a key driver of Kelvin wave generation. Right now, the MJO has remained coherent, partly because the El Niño background state is constructively interfering with it, amplifying its signal. We've already seen the effects of this tropical activity ramped up in the eastern Pacific recently, with named storms forming. Looking ahead, as the MJO potentially phases into patterns that favour the western and central Pacific, roughly phases 6 and 7 on the standard diagram, we could see 2 or 3 typhoons develop in the western Pacific around early July, each of which could generate additional westerly wind bursts and keep that feedback loop going. This is something the ensemble guidance is already beginning to hint at. Alright, so now let's talk about the big picture forecast, because this is really where things get striking. I want to walk you through how the major modelling systems have evolved in their outlook over the course of this year, because the trajectory of the forecast itself tells an important story. Back in January, the European model was actually anticipating a relatively modest El Niño outcome. Weak to moderate was the prevailing expectation heading into the spring. The spring predictability barrier, which is a well-known period of uncertainty in El Niño forecasting during boreal spring, can cut in either direction. Sometimes a developing El Niño signal fades once you're through April and May. Sometimes it explodes. This year, it did the latter. By the time March arrived with those westerly wind anomalies that kicked this whole thing into gear, it became clear that something more significant was developing. The European model progressively shifted its forecast more aggressive through April, then again through May, and by June 1st the picture had crystallised into something that is frankly remarkable to look at. The European Ensemble's latest long-range seasonal forecast for December is projecting what would unambiguously be classified as a super El Niño event. I've been doing this for a long time, and I cannot recall seeing a forecast this aggressive, this early in the calendar year. Not even back in 2015, when the last major super El Niño unfolded. When you look at virtually every major modelling system side by side for December, the European Ensemble, the American CFS, the North American Multi-Model Ensemble, they are all essentially telling the same story. The Niño 3.4 index is expected to peak somewhere in the 3 to 4 degrees Celsius range by November or December, which places this firmly in historically unprecedented territory. The North American Multi-Model Ensemble's mean forecast is actually calling for a peak of about 4.1 degrees Celsius. To understand what that number means, Anything above 2 degrees is generally categorized as a super El Niño. Anything above 3 is historic. We're looking at the possibility of reaching levels that have no modern precedent. The CFS ensemble is calling for a peak around 3.6 degrees on its mean, with individual members going even higher. Most of the ensemble members are showing values above 3 degrees. Even the relative Oceanic Niño Index, which is a more conservative measurement approach, is forecasting this reaching approximately 2.9 degrees. When even the conservative metric is in historic territory, you know the situation is serious. At this point in the forecast cycle, the spread of outcomes has narrowed considerably. The spring predictability barrier is behind us. The oceanic and atmospheric signals are both confirmed and coupled. The models are converging. My personal probability assessment right now, I'm placing essentially a 100% chance that we end up with at least a strong to very strong El Niño by fall. I'm placing at least an 80% probability that this reaches very strong El Niño classification. And I'm placing a 65% probability on this reaching what I describe as historic El Niño territory. That's 3+ degrees on the Niño 3.4 index. There's also a 35% probability, and I want to be direct about this because it's real, that this ends up in what I can only call uncharted territory, levels we have not observed in the modern record. The official NOAA Climate Prediction Center is also reflecting a high confidence picture in their probabilistic forecasts. They're showing essentially 100% probability that this remains a significant El Niño event through the year. For the strong to very strong category specifically, they're showing roughly 62 to 63% probability. There's about a 26 to 29% chance of landing in the strong Mudquartskui, but not quite very strong Narnharita category, and the probability of this being merely a moderate event, about 7 to 8%. So you're looking at maybe a 1 in 12 chance that this ends up being something ordinary. The odds are stacked heavily toward a significant, historically noteworthy event. What does all of this mean for what you can actually expect weather-wise across the United States? Let me put together the big picture for you. The atmospheric response is going to be substantial. Through August, September and October, expect continued enhanced convection and rising motion across the central and eastern Pacific. That rising motion in the tropics suppresses Atlantic hurricane activity. The wind shear, it generates tears apart tropical systems trying to develop in the Atlantic. I'm still expecting 7 or 8 named Atlantic storms, which would be a below average season. Meanwhile, the West Pacific typhoon season and the Central Pacific hurricane season are likely to be quite active. For the continental United States heading into late fall and winter, the dominant story is the Pacific jet stream. When El Niño is strong, that jet extends further south and east than normal, and it acts as a guided highway for storm systems rolling in from the Pacific and moving across the southern tier. California and the southwest, when it comes in from Bansam, you're looking at a potentially wet winter, with above normal precipitation that could include heavy snowpack in the Sierra Nevada at higher elevations. The Four Corners region, Texas, the Gulf Coast, the Deep South and the Southeast are all in the wet zone. More storms, more chances for winter precipitation events, and potentially some significant ice and snow events across areas that may not always see them. The polar jet, by contrast, gets suppressed and disjointed from the Pacific jet under strong El Niño conditions. This produces what we call large-scale blocking over Canada, and sometimes the Greenland or Canadian high-pressure pattern, which keeps the coldest air bottled up at high latitudes rather than flooding south into the central United States. For the upper Midwest and parts of the northern tier, this typically means a warmer and drier winter compared to last year. Much of Indonesia and Malaysia will see reduced rainfall. Parts of East Africa, on the other hand, tend to see above average precipitation during strong El Niño events. The European and American seasonal models are both showing widespread warm and wet anomalies, expanding through October, November, and December across the Pacific Basin, with that red tongue of above normal sea surface temperatures spreading even more dramatically westward. As the year progresses, the breadth and intensity of the atmospheric response projected for winter is consistent with what we've seen in prior major El Niño events, but potentially at a scale we haven't fully experienced before. I'll close with this. We're at an inflection point right now. The forecast is no longer speculative. The atmospheric and oceanic observations are confirming what the models have been suggesting, and the spring uncertainty window has closed. This is real, it's intensifying, and the trajectory points towards something genuinely historic. Whether this tops out in the 3-degree range or pushes into territory we've never charted before will become clearer as we move through summer and into fall. And I'll be updating you every step of the way. If this video gave you something to think about, something to prepare for, or just helped you understand what's actually happening out there across the Pacific, please hit subscribe and turn on notifications. I'm going to be doing these updates regularly through the fall season because the demand is real and the stakes are real. Share this with people in your area who need to hear it. As always, stay weather aware, and I'll see you in the next one.